Hello everyone, welcome to Math Q&A. Now, this is video number 3 of geometric sequences, and we're going to be looking at examples of a geometric sequence. Let's look at the previous example that we've had. We've had 1, 2, 4, 8. And let me just bring this down a bit. And we have also said that, well, if you take a division of the next term divided by the previous term and you find the same value, then that sequence is geometric. So 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. So this is a geometric sequence. And I'm also going to use this word just to make it straightforward to you. It's also what we call a quadratic series. So quadratic means the same thing as geometric. If you're more like you're more familiar with, like, binomials. A binomial has an x squared, So geometric sequences also have like exponents. So there's like a trend there. If you see exponents, these things have a relationship. So that's just a side note. But this is a geometric sequence, so we'll be dealing with like a little bit of exponents. So like going back to our equation, we've had Tn is equal to n multiplied by Rn minus 1. So let's actually now use this equation to find the equation for this sequence we're dealing with right now. Now, Tn, A, as it is the first term, which is 1, multiplied by R, that is the ratio, that is the difference, it's not a difference, it's the division, 2 minus 1, that means this common value which we find when we take divisions of the next term divided by the previous term. So, and that is 2 in our case, and then n minus 1. Now, let's say that if we have 16, let's say that Tn, or some value of our geometric sequence, is equal to 15. If Tn is equal to 15, they say, what is the value of n? Well, let's go use this equation that we have derived previously to find the value of n. Okay, so our equation right now is Tn is equal to 1 multiplied by 2n minus 1. And we know that now our Tn is equal to 15 is equal to 1 times 2n minus 1. Now let's solve this using equation rules. 1 times 2n minus 1 is equal to 2 exponent n minus 1. And 2 exponent n minus 1 is the same as 2 exponent n multiplied by 2 exponent negative 1. Listen up. If you multiply parts of the same base, you actually add the exponents. So now here it means that we can rewrite this thing as 2. Then from there, you just subtract n from this. So you just add them. You just say n plus minus 1, which is n minus 1. So this is equal to that. That's what I'm trying to say here. So we've got 15. Now from there, you've got 2n. Now, please note that 2 exponent minus 1 is the same as 1 over 2. And since we have got number 1 over 2, you can multiply by 2 over 1 on both sides. And from there, 15 times 2 is 30, is equal to 2 exponent n multiplied by 1, because these things cancel out. Okay. And then from there, to find n, we use log rules. Okay. Now, we can flip this and bring the 2n on the side and the 30 on the other side. So we've got 2n is equal to 30. To find the value of n, you can say n is equal to the log of 30 divided by the log of 2. This is the rule of logs. We use the rule of logs to find the answer to this. So n is equal to log 30. I'm going to bring the calculator here and say, well, log 30 divided by log 2. Now the value is 4.9. Now, in high school, I'm not sure if they allow you guys to actually keep a specific number of decimals after the comma, but depending on where you are in the world, well, this could be 1 or 2, but in South Africa, we actually only leave 1 in high school. So you're gonna say 4.91. 4.91. Okay, that is the answer, meaning that for term, if you have 15, then the answer is going to be 4.91. But now there's something very important I'm going to mention. That important thing is that in your class examples or in your exam questions, they'll never ask you a value. Normally, they'll never ask you a value which gives you 4.91 or a decimal number. They'll always give you a number, Tn, that is actually available in the sequence. Okay, so let's say, for instance, now they said Tn is equal to 16. Now, let's go into that example, because we know, based on this sequence, we do know that, okay, fine, from 1, 2, 4, 8, I mean, if you multiply by 2 all the time, when you get to 8, you multiply by 2, you must get 16. So let's see if we'll get 1, 2, 3, 4, 5. Let's see if we'll get 5 if we actually use 16. Now catch that example in the next video. Thank you.